doing an iPad.
When he says he's going to make some videos, give you a rapper.
What?
When he says he's going to be a rapper.
Okay, good. Good to know.
That's not
I
even
watched
possible.
them.
That's not even possible.
Okay. Let me see. Do your work, please. Plug in a 25. Forget me. How long did I go to school? Huh? I did. Let's see. I did 7 years of night school. I don't really think you can count that as years because I was taking 1 or 2 classes at a time. Probably that should be collapsed on now. High school, college, and then night school.
How about that? Just count
Count it as 7.
Yeah.
And I think it probably should be cut in half. Okay, so if I did it and I counted all those years, 5 plus 4 is 9 plus 7 is 16.
But now you're getting like 100,000 a year, aren't you?
About. Yeah. So we'll see if the calculator works. Okay, so what's the doctor making? Nice. 25 years. 25 years. What did we say Rigetti made? How many years did we count for me? 16 years. Okay. So, doctor making more than me, huh? That's all right. That's all right. I get to work with you guys.
Aww.
There's my reward. What did you get? 1,800. Okay. Good. We have time. Let's do that talk the talk. Okay. Talk the talk. Christopher B., could you read the talk to talk for us?
Why are predictions made by more likely to be inaccurate than predictions made by interpolation?
Okay, so I'm going to make a sketch to remind us kind of what those 2 words mean. We looked at this a little bit yesterday. If we were looking at our data, it's an increasing function, and you'd probably see dots like this. Okay, what our linear regression line is, it's taking and putting a line through those dots. Now, it doesn't exactly hit all the dots. Some are a little above, some are a little below, but it gives you kind of an idea of the pattern. So this is the linear regression line. And then the vocabulary that they're using is interpolation. I don't even know if I said that right. Interpolation is when you kind of look at the actual range of those dots and say, well, what about this year? Or what about that year? You pick a year that's within the bounds of the data that you got. And then extrapolation is when you look farther out. And say, if I know what's happening down here, can I make a prediction about that doctor? Here's that doctor. He's way outside of the range. Okay? Or here's Ms. Rigetti. I was a little bit less than the doctor. Okay? Okay, so extrapolation is when you look farther down the road and you kind of use this linear regression line to predict things farther out. Interpolation is where you look within the bounds kind of the data. And they're saying, why are predictions made made here more likely to be inaccurate than predictions there. Okay, so out of the range versus in the range. Why do you think you're more likely to be off out here? I'm going to walk around as you talk at your tables. Okay?
Why do you think?
Extrapolation, when you're looking farther down the road, why is that more likely to be off of your line? What may have happened? What do you guys think? Okay, so what way might you win? Okay, we'll go to the school more. We'll just carry it further down. Why would there not necessarily be such a close match to our line the farther you go?
Because he's not working much.
Okay, write that down. Maybe there's differences. Okay, why do you think you get to be a little bit off the farther you go on this line? That's the question. What are some of the things that could make it not match the pattern?
Maybe like they always do that 22, 5 years of school, right? And like those looking like wow.
Okay, so you're saying fraction of years don't actually fit the pattern? Is that what you're saying? Okay. What else? So we use these lines a lot of time to predict farther out, and sometimes that's off. Why do you think it gets off the line the farther out you go? Okay. Are you guys talking about what you're doing? Okay. So farther and farther out this line, the actual numbers get okay, so maybe it doesn't right something like that. Can't compare the farther out. It's not the same. Oh, interesting. Yeah. Nice. All right. What do we have, folks? I heard some good things. Okay. Farther out could be outlier zone. What's an outlier?
A data point that's out from presentation.
It's way off of everything else, okay? Why else might these numbers out here be off? I heard a lot of different varieties. What else? Vacation. Maybe those rich people stop working as much. Okay, so maybe they max out on how much they actually work. Who knows? What else? I heard different things around the room. They were all good. What?
I was encouraging other students to share their answers.
Okay, the wrapper table. Wrapper table. What do you guys have? Your answer here. No, you get to. Pick Rochambeau. Pick a brave person. We're all nice here.
Jackie's
Because you can't compare your answer to the close ones.
Compare. Maybe there's something about the far off values that make them different. These kind of have more to do with each other. Maybe they're jobs that are more similar to each other. Maybe the jobs that you get after working or going to school this long are different. Maybe they're wrappers and they're way higher. Okay? Maybe it maxes out and it levels off. Yes, Imogen.
Can it be like heavily skewed? Like not necessarily skewed, but like can it be like 1 point super up and then 1 point's like super down? Like,
Yes.
not super down, but like just like they just keep on like going intensely high.
It could be heavily skewed. We've seen skewed data, okay? So linear regression, one thing to remember is it's a pattern, but it's not exact. Things are a little bit off of the pattern. Extrapolation, you'll hear a lot. That's when you take the pattern and try to predict out of the bounds of what you actually studied. Try to make predictions ahead or explain things behind. All right, that's enough of this for today. Homework packet right now. Please put books away. Get that homework packet out. This is maybe a good time if you wanted to find a partner and talk about stats project, a general topic that you want to work on.
Martine also wants to
I asked her first. I asked her yesterday. No, I asked her yesterday.
Oh yeah, I got over there on Monday.
Do you want to see some of the projects from last year?
Yes. Yes.
Not really. So you can work on your, what do you call it, homework packet, but I'm going to show a couple. Let's see. Classes.
So did that. I saw. I did that blind. Actually, no, I want to When is this due again?
We don't have dates yet. Okay, that's, oh, here we go. This is Miss Rigetti's from last year.
You gonna do it online?
You do not have to do it online. You're going to make a presentation to present
or something?
like this, okay? Prom survey. I did some surveys in part because we were planning prom and in part to give example to the class. Sample. I did my survey on Google Form, posted a link. Students in my classes answered the questions. I kept data. Part of the question was, what are you, male, female, and what grade are you in? And one type of thing you're going to want to do in at least one of your questions is ask that kind of data and then show it, be able to, I'll show you how to make these kind of charts. 29 students or how many responded to my survey. Question 1, how many times have you attended the THS prom? Again, you want a number value or a number quantitative type answer. Most people have attended the prom from 0 to 2 times. There was one outlier who had attended 3 times already. This person must have gone to prom every year since they were a freshman. You will make a box and whisker plot with your data. My min was 0, Q1, 0. So a lot of people go to prom, 1 to 2 times. So min was 0. Some people were responding who'd never been to prom before. Median is 1. That meant half the people were lower than 1 and half the people were higher than 1. Q3 was 2. So 50% of my people were between 0 and 2. Okay, I didn't apparently have a whisker on that side, maybe because the numbers I'm working with were a small range. Okay, maximum was 3. So you will get a list of data back and you will make a box and whisker. You'll also make a histogram. How many times have you attended prom? Remember, this bin is everybody from 0 up to just below 1. This is everybody from 1 up to but less than 2. Here's everybody from 2 up to 3. And this tells how many people. I had, it looks like 8 people in the 0. It looks like 11 people, if I look across, who had attended at least once. And then it looks like 8 people again who had attended twice. And then 1 person here who had already attended prom 3 times. Okay. Other types of data we'll be learning how to do now. How much does the prom ticket price affect the likelihood you will attend prom? So you got to look at 2 things that go together. Ticket price and likelihood to attend. Ticket price was what I figured was a dependent variable, and likelihood to attend. And my scatter plot wasn't the greatest data. I didn't do the best job on this question. Okay? But I did plot it and did a linear regression. We're going to learn about correlation coefficient. That's that R value we've been talking about, and it tells you association. Okay? We looked at this also in bar graph form. And then question 2b, how does the price of food change as we get farther from THS? I didn't like my results to that first question there. I wanted something that would give me a good scatter plot, and that's what we're learning how to do now, where you have 2 things that you think may go together. You're going to do the survey, and they might not actually go together. But I knew we were going to, I kind of figured that the closer you got to the city, prices might go up. Okay, so I said farther away from THS, probably more expensive. That's what was in my head before the survey. So I picked an item of food that I thought I could find at a lot of restaurants. Okay? And I looked online at menus to get prices. Some of this kind of research could be online. I didn't actually call restaurants and ask them questions. This was all stuff I could Google and search. I said, oh, this place has burgers. What does it cost? This place has burgers. What does it cost? I also had to look at, though, where are they located? And I map quested the miles. All right? So the second question, we're going to do the kinds of things we're doing right now, and they have to have 2 variables to them that you think might have something to do. There we go. There's a scatter plot, and this is what a lot of data really looks like. When we're looking at our book and they're all in a line, hardly ever do things look like that. But you can, this is a linear regression line. It kind of goes through the middle of the points. And what it shows is a loose positive association. Food tends to get more expensive the further we got from THS or the closer we got to the city. The reason I was doing it to the city last year is prom took off from Berkeley down there. Okay, there's my linear regression line. According to linear regression, a burger should cost 6.61 in tamales. So this is the starting value. And then for every mile farther, we're going to go up by 8 cents. Okay? 0.08 in terms of dollars is it will increase in price by 8 cents for each mile you drive further from THS. That's what this equation would tell you. If you're at 0, this part goes away. That's the price of a burger in town according to my line. And that's, again, a prediction. The third kind of question, you're looking for a categorical data. It's not going to be a number, really. For my categorical data, students were asked if they'd prefer a glow cup, photo booth, or no favor at all. And then we're going to break it out by category, male, female, overall, and do some bar graphs where you can look at how do different categories compare. Okay, so that was overall females. Males split between photo booth and book. Glow cup, females almost twice as likely would prefer the photo booth. And we ended up getting the cup. You've seen the cup. I'll bring the cup in. Escape. Okay, so that was Miss Righetti's version. Miss Morell did an interesting dog one I'll have to find. Here's what other students did. Jake Pike did video games. Teresa and Vero did put down or bullying kind of thing. Sophie and Carme, social media. Horses. Phones. Pets. Sports. Basketball. Cell phones. Favorite sports. Music. Sports. How cold is it? Shoes. Best iced tea. Ice cream, oh, yum. Hours of sleep, Pepsi versus Coca-Cola, and so we can look at a couple of those later, but those were the types of surveys done last year. I need your calculators, everybody.